Let me review some things with you that we discussed earlier in the school year. One of the reasons that people hate statistics is because it's pretty easy to manipulate data to make people think the way that you want them to think. So we are going to take a look at some things that we discussed in first semester so that you know what kind of things that you should be looking for and what kind of questions you should be asking when you are presented with data in the media. So, our first unit was about data analysis. So let's remind ourselves of a few things that we talked about in our very first unit. One common way of displaying categorical data is using a bar graph. There's nothing wrong with a bar graph in and of itself, but the same information can be displayed in a pie chart. Depending on the situation and what information you are trying to convey, one graph might be more appropriate than the other graph. So sometimes the choice of graph could be a little misleading. Another issue we talked about when we looked at bar graphs is sometimes people try to be a little too creative with their graphs. In this example, instead of just using regular bars, we have a picture of a donut, a piece of pasta, and a pizza instead of a regular bar graph. When you look at the graph on the left, your brain does not just look at the height of the pictures. It takes in the width of them as well, which can be misleading. On the right, our y-axis starts at 4 instead of 0, which again can be misleading. It makes pasta look way more popular than donuts because the pasta bar is a lot taller than the donut bar. When you are looking at histograms, pay attention to the width of each interval. On the left, we have a histogram with a width of 5. On the right, we have a histogram where the bars have a width of 2.5. The graph on the left shows a trend, whereas the graph on the right shows more detail. So you need to pay attention to these small things as you are looking at graphs. Are you looking at a pattern, or are you looking for more detailed information? If you are given specific values that have been calculated, like the mean, median, mode, range, standard deviation, interquartile range, any of the calculations that we have done, you need to pause and think about whether or not your distribution has outliers, because some measures are more resistant to outliers than others. The mean and standard deviation are not resistant to outliers, which means that if there is an outlier, that those values are going to be affected by those outliers. So for example, if you have an upper outlier, your mean is going to be pulled in the direction of that outlier. So your mean is going to be higher because there was one extremely high value. Same thing with the standard deviation. One value that is either much larger or smaller than the rest of the data set will make your standard deviation a lot larger. The median and the interquartile range, however, are resistant to outliers. So when statistics are reported in the media, they can choose the mean or the median, whichever one best supports the case that they are trying to make. So before you react to a value, ask if that distribution has an outlier and whether the value reported is the best choice for the statistic to report. Again, with outliers. An outlier could be an inaccurate data value. It could be a remarkable occurrence, and it will heavily influence some statistics like the mean, the range, and the standard deviation. The second unit we learned about in the first semester was two variable data sets. Remember that the point of comparing two different variables is to see if there is an association. There is not always an association. However, just having an association between two variables does not mean that one variable causes the changes in the other variable. Typically, data shown in the media will only be data that shows an association between two variables. One way of showing association between two categorical variables is a stacked or a segmented bar chart. Sometimes these can be a little bit confusing to look at. The same information can be reported in a side-by-side bar chart. One thing to be careful with is when you are comparing two different populations, particularly populations with different sizes, it is better to use percentages or proportions than the raw data. Here, we don't know anything about the number of males or females surveyed, but we do know that those values have been converted to percentages to present this graph. When you are looking for a relationship between categorical variables, you are looking to see if knowing one value, so for example, knowing somebody's gender, helps you predict what superpower they would prefer. We can tell from this graph that females tend to prefer telepathy and flight as their superpowers, whereas males really want to know how to freeze time. Another way to display quantitative data is with histograms. You can have two histograms that display similar data. For example, this one here looks at whether someone was a high school graduate or not, and their total income. So one histogram displays the information for whether if they are not a high school graduate, the other histogram shows the information if they are a high school graduate. Like I mentioned with bar charts, it's good to use percentages because the populations might not have the same size. Then you can try to draw conclusions to see if there is an association between the two variables, whether or not someone is a high school graduate and their income. You can see here that people who are high school graduates have a higher maximum salary than people who are not. In general, people who are not high school graduates are more likely to have lower incomes under $20,000 than people who are high school graduates. Lastly, if we want to compare two quantitative variables, scatterplot is probably the best way to do that. There are a couple things that you should be careful with scatterplots. One is pay attention to the scale. The scale can be manipulated to affect the slope of the points on the scatter plot and make a relationship look more or less drastic than it really is. Another thing to be careful with scatter plots is people can get a little carried away by having different sets of data in different colors all overlaid on the same axes, which can make it a little bit confusing. In general, when we talked about scatter plots, we had four things that we discussed. The direction of the association, whether it was positive or negative. That had to do with the slope. The form of the scatter plot, whether it was linear, nonlinear. You can get more detailed and talk about exponential, quadratic, other types of functions. Whether it was a strong, moderate, or weak association. That had to do with how close the points were to the identified form. So if you said it was a linear form, a strong association would be pretty close to a straight line. A moderate association, the points would be a little more spread out, and a weak association, they would be pretty spread out, not a definitive line. Same thing holds true for nonlinear scatter plots. And then, of course, look for outliers. Those are points that deviate from the pattern. The last thing I want to talk about is how data is collected, because that can affect the data itself and how it's perceived. So, we discussed bias. A study is biased if it consistently underestimates or overestimates the value that you are trying to evaluate if you repeated the study many times. And we talked about a variety of forms of bias. First thing we talked about was a convenience sample. If a reporter is just going out on the street and asking whoever happens to walk by them, that's a convenience sample. It is not going to be very reliable because it's probably not representative of the entire population's opinion. Frequently, these produce underrepresentative data. Another source of bias that we talked about was if you have a voluntary response sample, where people choose whether or not they want to respond to a general invitation. This could be something posted online, asking people to take a survey, or a survey in a magazine, or anything similar to that. Generally, people who have strong opinions are the ones who respond to the surveys. So it's generally not representative of the population as a whole. Obviously, a random sample is the ideal sampling procedure, but it's not always feasible to get a simple random sample of an entire population, particularly if the population is large. Some different types of bias that we discussed are undercoverage, where some people in the population are less likely to be chosen or cannot be chosen because of the method used. For example, if you conduct a survey at school and you ask people who get off the bus, seniors are going to not be represented well in the results of the survey because a lot of seniors drive to school. So because of the way the sample is selected, it is biased towards younger students and students who don't have a car to drive to school. Non-response is when an individual chooses not to participate or cannot be contacted. There might be a specific reason that someone cannot be contacted. For example, if you are calling people to ask them about their commute time, people with longer commutes are less likely to be home if you are calling a landline for people who still have landlines. So they would be harder to contact because they are not home as often. Lastly, In general, response bias occurs when there's a consistent pattern of inaccurate responses to a survey question. This could be because people are embarrassed to tell the truth. For example, if you do a survey about if people wash their hands after they go to the bathroom, people are going to be embarrassed to say, no, they don't wash their hands after they go to the bathroom, so they are incentivized to lie to avoid embarrassment. That would be an example of response bias. So all of these things should be considered as you analyze data presented to you in the media. Let me give you one example. One of the data sources I've shared with you is the coronavirus data pack from Information is Beautiful. We're just going to look at this first graph. This says that the majority of infections are mild. And this data was updated 2 days ago. They update it every couple of days. This says that about 81% of people who get coronavirus have mild symptoms. About 14% have severe symptoms, and about 5% have critical symptoms. So in terms of the graph itself, things that could be misleading, well, why did they choose to have different colors for the bars? The mild symptom bar is a solid color, while severe and critical have this gradient. Having the gradient could make the bar look visually larger or smaller when your brain reacts to this graph. The other thing that's a little weird is they've rounded off the corners for some reason. So again, that might affect the way that your brain interprets the information. In terms of the data source and how they came to these numbers, it says at the bottom that this was a study of about 45,000 confirmed cases in mainland China. So questions that might raise. How did they determine what level of severity the symptoms fell into? If we're talking about confirmed cases, were these self-reported levels of symptom severity, or were these judged by a physician? It says mild is flu-like and they stayed at home, severe is it required hospitalization, critical is it required intensive care. What if somebody went to the doctor, thought they had the regular flu, were told they had coronavirus, and decided not to go to the hospital and decided to stay home? Is this based on their personal views of their level of symptoms? Did everyone who went to the hospital get classified as somebody with severe symptoms? Some questions about how the data was collected. This graph might also raise some other questions like, okay, does this hold true if you look at other countries? For example, Italy. Do they have the same distribution of symptom severity? So as you are analyzing some of these graphs and charts, you need to think about the way the data is presented. Is it a good choice of chart? Maybe a pie chart would have been a better way to represent this data. It's still the same data, but maybe that would have a different visual effect. Did they do anything too fancy with the graph to make it misleading? And then look at the data source. What questions are raised based on the way that the data was collected? The last thing is, what other questions does this graph raise? For example, does this pattern hold true for other countries? So, as you look through a variety of data sources and graphs related to the coronavirus, these are the things I want you to ask. Is the graph presented well? Are there questions about the data source? And what other questions does this graph raise? Please be skeptical of graphs and information that is presented in the media, because statistics are used to sway opinion. I'm not saying that any of the things that have been presented are necessarily incorrect, but statistics can easily be manipulated to affect people's perception. So please, as a whole bunch of information is thrown at you during the coronavirus, during elections that happen later in your lifetime, whenever, please ask questions.